Okay, good morning, dear students. Today I will discuss about the biofuel and the tidal energy. This is the part of Unit 1. Subject name is the Power Plant Engineering. Semester is 7th. This is the outline. Introduction about the fuel and biofuel. Common example of the biofuels. Why biofuels? Classification of the biofuels. First generation biofuels. Second generation biofuels. Drawbacks. Futures of the biofuels. Tidal energy and the tidal power. Tidal energy technology. Tidal energy in India. Fuels. What do you mean by the fuels? Fuels are the any material that store potential energy which can be practically released and used as heat energy. Fuels are required for a variety of the purpose but are utilized mainly for other purpose. That is our transportation, power generation. What is a biofuel? Any hydrocarbon fuel that is produced from the organic matter, living or once living material in a short period of time, that is a day, week, or even month, is considered as a biofuel. So it is the consisting of the hydrocarbon fuel, which is the having of the living or the once living materials. That is the name as the biofuel, and it is a short period of the time. That is the it may be of the days, week, or the even month. Biofuel energy is derived from the biological carbon fixation. It can include the derived from the biomass conversion as well as the solid biomass liquid fuel. Common example of the biofuel: ethanol, vegetable oil, animal fats, green diesel, cow dungs. Why biofuel? Environmental aspect. क्यों हम उसको सेलेक्ट करते हैं, बायोफ्यूल क्यों लेते हैं? तो इन्वायरमेंटल इफेक्ट एस्पेक्ट जो है, इट इज द मोस्ट प्रोमिनेंट, renewable and the sustainable, reducing the greenhouse effect, cleanly burning. Socio-economic aspect. How? What is the meaning of the social economy offset? That is social economic aspect. Increasing energy security, boosting profitability of the agriculture, controlling wastage. Life cycle of the biofuel. The life cycle of the fuel ends in the distribution to the end user. कि कहाँ से हम स्टार्ट कर रहे हैं, कहाँ पे वो चीज फिनिश हो रही है. That is called a biofuel. Life cycle of the biofuel. It is a transportation, biorefinery, conversion, distribution, end user, feedstock. So biofuels life is fuel cycle, that is the consisting of the number of the terms, that is a transportation, biorefinery, conversion, distribution, end user, and the feedstock. The feedstock, it is coming from the raw material. Classification of biofuels, that is the first generation of the biofuels, second generation biofuels. First generation biofuels, they are also called as a conventional biofuels. The first generation biofuels refers to the fuels that have been derived from the source like the starch, sugar, animal fats and the vegetable oil. इसको जो है starch, sugar, animal fats और vegetable oil से लिया जाता है, and oil obtained using the conventional techniques of the production. Oil को जो है conventional technique of production से लिया जाता है. And the first generation biofuels are the biodiesel, green diesel, bioethers, biogas and the synthetic gas. First generation of the biofuels, that is alternative fuels for the diesel engine made from the vegetable oils or the animal fat, meets health effect testing CAA, lowering emissions high flash point greater than 300 F, biodegradable, essentially non-toxic. This is the mostly used in the European country. This is the first generation of the biofuel. It is the mineral acid and the chemically known as the fatty acid, methyl. It is very commonly used when it is mixed. Green diesel, it is also called a renewable diesel. It is the form of diesel fuel which is derived from the renewable feedstock rather than the fossil. Green diesel feedstock can be sourced from a variety of oils, including the canola, Elais, and the California, in addition to the tallow. It is chemically similar to the traditional diesel fuel. So green Diesel can be used in petrol tanks, trucks, pumps, and the automobile. Bioethers, it is made from the ether, wheat, or the sugar beet. It can also be produced from the waste glycerol that result from the production of biodiesel. They are also cost efficient and they reduce the engine wear and toxic exhaust emissions. Its energy density is about half of the standard diesel. Biogas, it is a methane produced by the anaerobic digestion of the anaerobics. Biogas, it is a mixture of consisting of 65% methane and the 35% of the carbon dioxide. It is a renewable energy resulting from the biomass, and it can be recovered from the mechanical biological treatment wasting processing system. Farmer can produce the biogas from the manure from their cows and using the anaerobic digester. This is the producing of the biofuels. It can be done by the biogas plant, gobar gas plant, also known as a gobar gas plant. Already studied in the school time. Floating gas holder type of the biogas plant. All the things and all the components are clearly shown. Inlet where the mixture is coming from the sides. Outlet where the gas is coming from the another sides. This is the outlet for the biogas where the gas when they producing after the processing. The mixing tank, it is here slurry of the cow dung, that is the mix up with the water. It is here inlet pipe which is going into the connected with the, this is the system. Dung and the water mixture which is connected in the, this is the system. Underground deester tank which is connected to the system. Outlet pipe which is connected to the spent slurry overflow tank, and the partition wall. This is the partition wall dividing the, all the things clearly where the mixing is done by the properly manner, and the support for the pipe, it is here represented. So this is called a floating gas holder type of the biogas plant where the biofuel can be generated. Second generation biofuel, also known as the advanced biofuels, produced from the sustainable feedstock. What separates them from the first generation biofuels? The fact that the feedstock used in the producing second generation biofuels are generally not food crops. The only time the food crops can be act as a second generation biofuel is if they have already fulfilled their food purpose. For instance, these vegetables is a second generation biofuels because it has already been used, is no longer fit for the human consumption. Example of the second generation biofuel, many second generation biofuels are under development, such as the cellulose ethanol, LS fuel, biohydrogen, bioethanol, biodMF, Fischer tropism diesel, biohydrogen diesel. This is also called electricity generation powered by the biomass. This is the also known as the another types of things in which all the processing are the showing here. This is the biomass which is the carrying from the outside combustion chamber. It is after the processing of the biomass steam boiler. After the combustion chamber steam boiler, it is taking of the steam for pollution control, exhaust gases. It is coming from the combustion chamber going into the pollution control chamber. Water which is coming from the steam condenser side and going into the steam boiler where it will be converted into the steam form. Steam valve which is using for the supplying of the steam to the steam turbine, and the speed control, ये जो आप देख रहे हैं speed control लगा हुआ है, controlling of the alternator जो रहता है इसकी speed को control करने के लिए इस्तेमाल किया जाता है. And the AC power which is using is here producing of the AC power from this alternator synchronized generator is presenting is here, and the cooling water which is supplying from the cooling tower sides, electricity generation powered by the biomass. Drawbacks: biofuels, particularly those derived from the palm biodiesel blends, may be the more carcinogenic than the conventional fuels. Biofuel is not truly carbon neutral because of the stages of the production, transportation, and the processing require the non-renewable energy. Fermentations and the distillation of the first generation biofuels create a negative net energy. Threat to food security in the poor countries may destroy traditional crop productions. Economically feasible production of the ethanol from the cellulose could happen within the 10 years. Safe and pollution-less biofuel factory will be constructed. Improved and the efficient biogas plant will be invented. New and less costly energy sources will take place. Food security will be regained. Fuel and the food price will decrease. Disadvantage of using the biodiesel produced from the agriculture crop involve the additional land use as the land area is taken up and the various agriculture inputs with their environmental effects are the material. Switching to the biodiesel on a large scale require the considerable use of the urban area. Biodiesel, this is the less suitable for use in the low temperature. जहाँ पे low temperature है वहाँ पे biodiesel ज़्यादा use नहीं कर सकते than the petrol diesel. Biofuel energy, that is the industry overview. Development of the biofuel that is at an nascent stage in the India, but is being actively pursued to the reduce India dependence on the oil imports. With the 70% of the crude oil requirement being met through the imports, the government is promoting use of the biofuels. Biofuels primarily comprises of the ethanol, biodiesel. It is made from the sugarcane. Biodiesel it is made from the jodhpur seeds. Biofuels has a significant growth potential in India. That is too much. Where all the things are clear, and it is a government initiative mechanism where the expand the production capacity and the minimize the price fluctuations of the key raw materials. Production distribution of the biofuels. This is the graph where the biofuels, ethanol mixed petrol were used by the yellow, and the green were used the Jorthupa biodiesel, and the ethanol and the Jorthupa that is represented in the Andhra Pradesh, Karnataka, Pondicherry, Tamil Nadu. This is the drivers and the challenge. Drivers is that is the increasing energy demand and the rising oil price. National biofuel policy support from the automobile manufacturer. Challenges that is a raw material supply constant. अपने पास चैलेंज बना रहता है कि किस तरीके से इसको हम जनरेट करें. फूड वर्सेस फ्यूल रहता है. लैक ऑफ द कॉस्ट कॉम्पिटिटिवनेस, यहाँ पे बहुत ज्यादा दिक्कत आती है जहाँ पे कॉस्ट की बात आती है. Tidal energy, it is another part. Also called the tidal energy, tidal power, a form of hydropower that converts the energy of the tides into the useful power, namely electricity. Causes of the tide, that is the gravitational force of the sun, moon and the earth rotation. 2 tidal cycle per day, that is the 12 hour, 25 minute. Tidal range, large at the coastal region with the high depth gradient. Water can be stored in the estuary during the high tide and the release during the low tide through the turbines. Plant location, tidal mills built in the inlets branching of the tidal estuaries. Average tidal range, that is the higher the better. Visibility of the plant constructions and the basin closures. Environmental consequence. It's a huge dam built across a river estuary. When the tides goes in the and out and the water flows through the tunnels in the dams. Tides coming in the sea is the turbine generator, that is the production of the tidal power. It is the tide going out when the tide is coming and the tide is going out. दोनों ही केस में जब टाइड आता है तो ही पावर जनरेट होती है, जब टाइड जाता है तो भी पावर जनरेट होती है. So tidal range has to be excess of 5 meters for the tidal power to be visible. The purpose of this dam or barrage is to be water flow through it into the basin as the tide comes in. As the tide needed, gates in the barriers that contains turbines are opened. The hydrostatic head causes the water to flow through these gates, driving the turbines and the generating power. Power can be generated in both directions through the barriers, but this can be affected efficiency and the economics of the project. Okay, and the components of the barrage, this is also known as caissons and the turbines. Tidal energy introduction, a form of the hydropower that converts the energy of tides into the electricity or other useful forms of the power. The first stage scale tidal power plant, that is the Rachel Tidal Power Station, started operation in 1966. Historical tide mills have been used both in Europe and the Atlantic coast of the North America. This is the Lawrence Tidal Barrage Power Plant, which is also describing in the picture. Tidal current turbines. It makes use of the kinetic energy of moving water to the power turbine in a similar way to the wind turbine that use the wind to the power turbines. Operates during the floodeds and the ebb tides. Consist of a gearbox, a rotor, and the generator. And these 3 parts are mounted on a support structure. Tidal energy technology, there are basically 2 methodology for creating tidal power by building semi-permeable barriers across the shores with a high tidal range to dam the water. by harnessing offshore tidal streams. Tidal streams can be harnessed using the offshore underwater. Since India is surrounded by a sea on three sides, its potential to harness tidal energy has been recognized by the government of India. Potential sites for the tidal power development have already been located. The most attractive locations are the Gulf of the Cambay and the Gulf of the Kochi on the west coast, where the maximum tidal range, that is the 11 meter and the 8 meter. The Ganges Delta and the Sundarbans is the West Bengal, also the good location for the small scale tidal power. Tidal schedule vary from day to day since the orbit moon does not occur on a regular or 24-hour daily schedule. Instead, moon rotates around the earth every 24 hours 50 minutes. During this time, tide raise and falls twice, resulting in the tidal cycle, which lasts for the 12 hour 25 minutes. Tidal range, that is the water elevation at the high tide, A minus of the water elevation at the low tide. Rise and fall of water level follow a sinusoidal curve. The average of the time for the water level to fall from the A to B approximately equal to the 6 hour 12.5 minutes. During the full moon, new moon, when the sun, moon, and the earth are approximately in one line, the gravitational forces of the sun and the moon are the enhanced level, making the high tides, which are called as spring tides. Near the first and the third quarter of the moon, the sun and the moon are at a right angle to the earth. Neap tides of the tidal range of the small occur. The range varies during the 29.5 day lunar month. It is a maximum at the time of new and the full moons. In the single basin, single effect tidal power scheme, the basin is filled by the keeping the slices open and letting the water flow from the sea to the basin during the high tide. And the power is produced by the letting the power flow from the basin to sea through the turbine during the low tide. In the single basin, double effect tidal power scheme, power is generated during the high tide with the water flowing from the sea to the basin through the turbines also during the low tide. Even low tide and the high tide, the power will be produced by the tidal basis. In the linked basin, double basin effect power scheme, there are the two basins on the land side with the powerhouse located in the barrier between the two basins. So this is the today lecture. This is the discuss today another form of the removal time of the energy.